I'm super excited to be here telling you what the Agent 3 launch was like. So one of the things that we wanted to do with Agent 3 was give the agent more autonomy. What is autonomy? It's basically the agent should be able to do more work by itself without asking the human for assistance. So with that in mind, I'm going to be covering two important things that we released as part of the Agent 3. First one was testing. We gave the agent the ability to do testing by itself. And the second one was, it's a different kind of autonomy, but we let the agent build more agents by itself so that instead of being a build time autonomy, it's now a runtime autonomy. So let's go with the first one. Ever since AI came to the world, all of our workflows have changed. Every engineer has had to shift the way they build software. They run software, they test software, everything else. But traditional engineering or trad engineering had some good ideas. They had some best practices that actually are good. One of those best practices is testing. Why is testing important? Testing gives you autonomy. Whenever you're defining software, you're also defining some tests in software. And you encode hypotheses. Like you say, I expect that if this happens, my software should behave this way. And it should have this observable side effects and whatnot. So that means that you write your software and then you make changes to your software and you run this set of tests and they autonomously go and validate all your hypotheses. And if something's wrong, it tells you and then you go fix it. So I'm going to give you a case study. This was the Agent 2.0, the previous version of the agent. For those of you who are not super familiar with Replit, Replit is a app building application. So you go to replit.com, you ask, hey, make me an application that displays a map for local landmarks and add all the functionality that you want. And then it just goes and builds it. Within a few minutes, you should have a full application, all of your of the properties that you asked the agent to build, it'll build it. But now there was one small problem. Yes, it built the application, but if you zoom in, oh no, Replit is asking the human to go and test it. So despite the human asking the Replit agent, hey, please go build me something, there's this inversion of control where Replit agent is telling you, hey, by the way, please go test it. I don't want to do it, or I can't do it. Most of you are probably very familiar with a diagram similar to this. This is an oversimplification of what an agent is. It is basically a big LLM call loop where you send the user prompt to it, and then it goes and makes actions that affect an environment. These are typically done through tool calls. And then after the tool call is finished, it goes and inspects what has changed in the environment. This is like a feedback loop kind of thing. And then just repeats itself over and over and over again until it thinks that it has finished the request. Once it's done, or if it cannot continue doing the request, it just hands control back to the user. So that's all in good. Now, because Replit Agent 2.0 didn't have the ability to test the applications by itself, this part of the diagram went wrong. It couldn't continue too often, and therefore it had to hand control over to the user pretty often. So testing is great for this. Testing should have solved this particular problem, and that's the whole reason why we built the ability to test by itself. You may have remembered in the past few presentations, there's a lot of options to do testing. You have OpenAI Operator, you have Anthropic Computer Use, you have open source frameworks like Playwright, Cypress, and Selenium. Now, while we were choosing the options for implementing this, Operator and Computer Use super powerful. They're also very expensive. They're also very slow. Normally, expensive and slow go hand in hand. So we were left with trying open source tools and also some vendors. We eventually settled on Playwright because A, it's open source, B, it leverages some of the team's strengths with TypeScript, and also it happened to be like the right combination of properties of like being able to extend it, being able to inspect a little bit of what was going on, about the inner state of Playwright. We didn't go all the way to using Chrome DevTools like the browser side people, but this was the right balance for us. So eventually when we ended up building with Replit Agent 3 was we really had ways of running a browser in your development application. So we added the ability to write Playwright and to interact with the browser using Playwright. And now when the agent thought it finished a request, it can go and test itself, or rather, the application that it just built. And not only that, it can go and do also a list of tests. And then if it finds a bug, it will report the bug. And then it'll fix the bug. So that means that more often than not, the agent will be able to self-heal itself. Of course, not perfect. But more often than not, this happens. So now our new diagram looks a little bit more like this. Instead of passing control back to the user when it thinks it's done, when testing is enabled, it will then run tests and only give back control to the user if tests pass and also there's nothing else to do in the task list. That means that now the agent can do a lot more on its own. And we have some pretty good stats. 90% of the time the testing agent was involved, it was a success for autonomy purposes. That means either the test passed or the test failed and it was able to fix it. 40% of those were bugs that were found and then fixed. So from autonomy perspective, fantastic. So, some other stats that we're very proud of is that the cost per test is 20 cents per run median, which is a pretty good return on investment. Now, the agent can go and fix bugs that you would need to have to go spend some time, click around, then explain to the agent, hey, this failed because of this, and this. Now the agent can just observe the whole trajectory and figure out what exactly went wrong and self-heal. And I said before, this is not perfect. We still have about 4% human escalation. This is mostly due to things like CAPTCHA or logging into some other sites, etc. Still, overall, net win. This is one of the things that we're most proud about the Agent 3 development. Now, I mentioned that this was build time autonomy. What about runtime autonomy? Agents building agents is something where you can delegate tasks for the agent for another little software to do. Normally, when Replit builds an application, it just builds something semi-static. There's no more autonomy behind it. But what happens if you need a different kind of autonomy? What happens if you need to build something that, I don't know, every day goes and fetches market data from the S&P 500. And then, once it's fetched, summarizes that information, and then sends you an email. This is not possible with regular websites or regular applications. You do need something a little bit more agentic. So this is similar to the previous diagram that I showed. This is more or less the inner state machine of the agent that the Replit agent builds. Very similar to the other diagram, but instead of having the escalation back to the user, since this is supposed to be an automation, it always returns an output. Sometimes this output is, hey, something went wrong, this is an error, but it'll always just results in an output being sent to the user and consider it done. But the core agent loop is still there. There's still an LLM call. There's still some actions or tool calls that modify an environment or use an environment, and there's some feedback back to it. One day, you wake up and see that, oh no, there's no email. What happened? You open your favorite LLM provider's status page. Oh no, they had an incident today. So you can see that there's a lot of failures whenever there's models involved. We all know that models are non-deterministic, so this is kind of expected. So in reality, the state diagram looks a little bit more like this. That particular LLM call is faulty. It doesn't work all the time. But wait, Luis, you showed that the reliability of LLMs is about 99.8%. So that means that most of the time it works? Yes, but this is being called in a loop. That means that for any agentic workflow, this particular LLM call is going to be repeated, I don't know, 5, 10, 100 times. So that means that it's not quite 99.8%. It's actually way worse. So this is a plot of the expected reliability of a workflow that has between 0 and 100 steps. You can see that about 50 steps in, the reliability drops from 99.8% to 90%. So that means that 1 in 10 times, your workflow will fail. If you go back to 100, it drops to about 80-something%. So now you're looking at something a lot more faulty. Of course, the LLM is faulty, yes, but it's not the only part of the system. The graph actually kind of looks like a little more like this. Also, the actions can fail. Whenever you're, I don't know, crawling a website, that code could fail, or sending the email could fail, or any step in the process can fail. I don't want to be super pessimistic, but failure is not only not an option. Failure is inevitable. You need to contend with failure. And because we know this is a fact of life, we're not pessimistic, we embraced the Zen and decided, like, okay, what are we going to do about this fact of life? We relied on two very important pillars when building agents. First one, Mastra, new logo, by the way. You'll know Mastra, one of the best agent building frameworks in TypeScript. And we also recruited the help of this other framework called Ingest. Ingest provides durable execution. Super quick idea behind durable execution. Whenever you're building software, instead of just like going bam, 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 bam on all the instructions, whenever you declare something using durable execution, you can resume from a point in execution if something fails during a block. So that means that instead of having to restart your workflow from the very, very beginning, you can now restart it from somewhere in the middle. This allows your application to recover way, way faster and way more robustly. So that's all great. You might have heard that involving durable execution might be a little bit more complicated. You need a slightly different programming methodology. You do need to like structure your code differently. But thanks to Mastra, this is an example of a regular Mastra workflow. This is I just literally copied it from the documentation. You can see that you're creating steps. And then later on, you will chain those steps in a workflow. How do you add durable execution? Tweak a few of the import statements, construct wrap your functions to create workflows and create steps in a wrapper, and that's it. The rest of the code is as is. The fact that most of the code stays as is also fantastic for agents because models have already been trained with a great corpus of API examples that don't necessarily have durable execution. So that code stays the same. From the LLM's perspective, no changes have been done. It's only the preamble that has changed. Great for LLMs, great for humans, great for the actual workflow that you're doing. Okay, so what is the actual impact of doing this? From the very pessimistic 80% success rate that I mentioned, it went up all the way to 96%. Of course, this is LLM written code. So that means that there will still be failures that are unrecoverable, but just the fact that it was able to recover this much was a huge success. And I was super proud that this is a primitive that we build for users, and our users don't need to think about this. It just comes out of the box. So yes, failure is inevitable, but failure is also engineerable away. If you go out of this particular presentation with two things. Testing is fantastic. Always invest in testing. And also, durable execution is also a great tool to have in your toolbox so that you don't need to worry about the inevitability of failure. That's all I have. My name is Héctor Chávez, CTO of Replit. We're hiring if you're a TypeScript engineer and are interested in building the next generation of agents.
Anyone has questions for Luis?
I have a question about vibe coding. So you build a Replit as one of the most used vibe coding tool out there. Do you yourself use vibe coding in your day-to-day? And what is the percentage you will say of code you ship today that is vibe code? And how test, if you use test, how do you use test to make that vibe coding reliable? Because now you have, for your user, you're adding that MCP, but how about your workflow on day-to-day?
Yes, so of course, we all vibe code. At Replit, because Replit is mostly used for building like internal tools or proof concepts or applications that start mostly independent of the rest of the code base, almost every single one of our internal tools are built with Replit. There's other families of tools that we've enabled to be more amenable to vibe coding. So the percentage of overall of new code is kind of high, but it's not as high as you would expect. Now, of course, we do use Replit ourselves to build parts of Replit, and for those parts of Replit, we do use a testing agent. It's the fact that we are dogfooding our own product is really helping us improve things super quickly.
On your presentation, you had a P50 cost estimate of 20 cents. Do you remember the P99?
It's 40 something, I think.
Okay.
Cents.
Okay.
Yeah, so it's twice as much, but it's the P90, 95 or 99.
Well, that's a really short question. I'll take one more. The one in the back. Oh, good.
Hey, I'm curious, like, there was an instance, I believe, like 3-4 months ago where Replit had an agent running and the production database was effectively destroyed because of that agent. I think it was covered fairly widely. I'm curious what were the main lessons learned from that instance?
Yes, so lessons learned. We had been working on a dev prod separation for 3 months prior to that incident. So the fact that we hadn't shipped the dev prod separation by then was really painful for us. Like, we had the solution there, it's just that we hadn't shipped it. So since then, what have we learned? We are very diligent in adding dev prod separation everywhere. We also added a lot of guardrails around at least letting the agent know, like, hey, you're touching something with production, versus this is safe to touch and modify or everything, because this is for development purposes only. So that dev prod separation, everything we build, we now build it at least with dev prod separation in mind, so that by construction it shouldn't happen anymore. Now, of course, there are some resources that are a little more challenging to make a full dev prod separation. Like, for example, if you are connecting your Salesforce instance, you might not have a testing Salesforce instance. You might only have access to production one. So we're also trying to communicate this better with users, and also create UX patterns so that this is very clearly visible.
Well, thank you so much. We're over time, and really appreciate Luis. Please give him a round of applause.